So let's wait 2 more minutes before more people join. Okay, let's get started. So today I'm gonna quickly uh, go through the topics we're gonna cover in our final exam. Uh, so so let's get started. So again, the final information is it's gonna take place on Monday from 10:30 to 12:30. So you will have 2 hours to complete the finals. And again, it will be the same as what we do in the as what we did in the midterm. We're gonna upload the final exams on the Blackboard at 10:30, and you're gonna download the finals and start to work on it. And for the exam form, it is meant to be a closed book, no internet access or cheating activities. But honestly, at this very special circumstances, there's no way I can monitor your exam behavior. So all of these will be on your own honor. So I hope all of you can respect the honor protocol and just do your stuff on your own. Of course, if you have, because you're also attending other classes, right? If you have, if other lecture instructors have some some specific effective ways to regulate the final exam. If final exams, you can let me know. Maybe we can adopt it to make sure everyone is fair, is fairly treated. So, okay, I forgot to. So for the format of for the question format, there will be. Let me bring up open the whiteboard. So, as some of you have requested, we designed the finals into this form. So there will be true and false questions. I think there will be around 10 true and false questions, and there will be some multi-selection questions. Maybe also around 10, but the final the exam is not it's not finalized yet, so the number may vary, but the type is all you need to know. There's some multi-selection questions, and then there will be short answer questions and long answer questions, right? So short answer and long answer questions. So for these two, we have included these two types in our midterms, right? So for the short term, for the short answer questions, usually we talking about the answers within like 3 sentences. But for the long term, you need to explain the details in a more formal way. So this will be the format for the final. Let me see, question for Taos. Which question? Yeah, yes. That will be specified. We will have a category clearly listed, so you know what to expect for each questions. Okay. And that's pretty much for the final exam as well as the format. Any more questions you want to know? Okay, if no more questions, then we're gonna go through the topics we're gonna cover, and specifically the finals will cover most of the stuff we learned in the second half. So remember the first topic we learned after the midterm exam is the public key infrastructure. All right, so oops, it's here. So you need to know a big picture of the PKI. What is the main component involved, and what does it do? What functionality does it provide, and what's the main components involved? So remember the big picture, and inside the PKI, the certificate is a very important or core piece, right? Certificate is the way that we can authenticate a particular message, right? And here, you don't need to worry about the detail of 503 certificate. We're not gonna ask any detailed question about it. Just know, you just need to know how we generate and use certificate to secure the public key communication. And for the trust models, we mentioned 2 different types. One is the strict hierarchy model, and the other is the network model. You need to know how they are structured and what's the difference between them, and how they are formed in network. And particularly for the network model, we have the mesh configuration, and I think there's a typo here. It should be hub and spoke configuration. So these two different configurations specify the different ways that the trusted, the certificate authority are connected, right? So in these 2 different configurations, the connection in the network is different. So you need to have some idea about it. And the PGP is a pretty good policy, is the main policy we use for the mail service. And you need to know how this service is implemented. And when one sending an email to the other, how does the one trust the other's public key, right? So that's pretty much for the PKI. And next we're talking about the operating system security. And there's some basic knowledge you need to know. So the system mode and the user mode are two different things, and they, what's the differences? Of course, what's the differences? So basically the system mode, you have all the access to, you have the access to all the resources on your computer, right? And the user mode is designed, is more specifically designed to restrict the resource access for the normal user, for the normal users, so that you can reduce the risk that a malicious user crash your system, right? So there are normally two modes, and the shift back and forth between the two modes. How do we do that? We have the system call API help us to jump from the user mode to the sys mode, right? So these are the background knowledge you need to know. If you've already taken the operating systems, then you shall be comfortable with this. And we talk about two types of kernels. One is the monadic kernels and the microkernels, right? We discussed the advantage and disadvantage in both. So in the monadic kernels, we put everything into one piece. So usually it's more easy to, it's more efficient for the process communication, for the resource sharing, right? Because everything is in the same space, so that the inter-process resource massive transmission or resource sharing is more convenient, more efficient. But the maintenance, for the maintenance wise, it is much more harder, because you have everything put in the same, put in one basket, and the debugging and maintenance can be hard. And differently, so comparatively, we have the microkernel architecture, where we modularize each function unit, right? We separate them so that it is much more convenient to maintain and debug. Right, but the splitting of those functional unit will cause some problems. Not the problems. Needs additional module to handle the inter-process communication. Right, that's why we have the IPC module here, particularly in the microkernel architecture to help handle the message exchange between the process. So you need to know how the IPC works, what is the vulnerability in it, right? What is the security vulnerability in the IPC? And then we have the permission. We have the permission in our Unix system. So all those are 12 object permissions, or we mentioned about, like read, write, execute for different subject, the owner, the group, and other users. And particularly, you need to know what's the functionality of the set UID and set GID. Right? Of course, we also mentioned the set bit, sticky bit. But for the test wise, we're not gonna mention too much about that one. But set UID, set GID is the one you need to know. So the purpose of these two is really for really to let the normal users being able to access some resources that he needs but not given, right? So normal users may not have the privilege to run some resources, but application-wise, that resources is a must. Then the application can use the setUID or setGID to grant the external or extra privilege, particularly when the user runs that application, right? So it's really for the convenient purpose, but if misused, this convenience can turn into security vulnerabilities. So these two permissions you need to know. Then for the attack wise, we talk about we mentioned like three types of attack in our operating system security. The first is the input validation. Right, we in the slides we talk about the SQL injection. So if there's no so for the SQL code, if there's if there's no specific validation in the input parameters, then the attacker may manipulate the input, let it include some extra SQL code, right? So that when the input is interpreted by the database, it will operate some actions that is not intended, right? So this part you need to know, and in the exam we will particularly have we will have some questions relevant to that, and some of for example, we will give a piece of SQL code and let you to be the attacker. How can you design the input? How can you design the input to achieve an attacking goal? So this is one thing. This is for the input validation. And for the second one, very important topic is the buffer overflow, right? So you need to know the memory layout. You really need to know how the stack grows when the program runs, right? Particularly when one program, when one process calls another, what will happen in the memory layout? How does it store the all the status information of the calling process and allocate the necessary chunk for the callee process? Right, so this will be lecture slides. Let me see. This should be this should be in lecture 28. No, it should be 27. Right, so in lecture 27, yes. So the buffer overflow. And given the vulnerability, what is the usual ways we defend it? Right? We mentioned 2 or 3 applicable defense mechanisms that can help us help us fight against the buffer overflow. Right? And the last kind for the software vulnerability is called the integer overflow. And the problems, the main problems, the vulnerability is mainly caused because of because of the implicit typecasting, right? In most of the case in the C language, right? Implicit typecasting is the one main cause for the integer overflow, and also the second reason is the insufficient bound checking. Right? If you don't check the bound carefully, then some operations like the plus or minus operations can easily lead to the integer overflow. Then we finish the security topics in operating system as well as the software. And for the malware, we introduce a lot of different types of malware, right? For example, the Trojan, the backdoors, the virus, the worms, and the bootnets and rootkit. So we describe different types, and for each of them, you need to have a clear mind. What are the differences in their goals, and what are the differences in their implementation ways? So for some of the so for example, for the Trojan, what's the goal of the Trojan? What's the goal of the Trojan horses? Is it tries to duplicate itself under the radar? Or its goal is just to stay low and survive in your operating systems to sneakily steal some personal information? Right, so you need to know the goals. Yes, correct. That's correct. So you need to know the different goals, and based on the difference in their goals, obviously the implementation ways will be different, right? For example, the virus, for the virus, the goal of the virus is to duplicate itself as much as possible while stay undetected. Then because it needs to duplicate itself, it has some executional piece of code involved, which means that it will add additional portion to the attached program, making the overall size to be larger, right? Then this can be a hint for the detection system. Then how does the virus, what the virus can do to eliminate the chance of being detected, right? It can so it can compress itself in certain ways so that the overall size for the bundle program will be unchanged. Now, what the detection system can do, it can no longer check the existence of the virus based on the size of the program, right? Then it needs to be a bit more smarter to do some binary bit pattern recognition. Right, so these are the things you need to know, and they're all included in the slides. Then in the network attack, we learned two types of attack. The first is the denial of service attack, and the DNS poisoning attack. So for the denial of service, you need to know the details of the TCP three-way handshake. How's the three-way handshake being performed? Right. So how's the acknowledged number, and how does the acknowledged number as well as the synchronized the sync number being generated and being configured? Right, so just in case you forget about the details, when we're doing a TCP handshake, three-way handshake, we will have a client. We'll have a client, we will have a target server, and not necessarily to be a server, just a client that is just a target that you want to communicate with. So at the very first, the client will send a what? Sends a SYN packet, SYN TCP packet, claiming that I want to build a connection with you. Right, and in this SYN packet, what is generated? It will generate an initial sequence number. And this number is a random one. All right, let's say it's 1001. Of course, it's not that short. It's just for the illustration purpose. And for the first SYN packet, what is the number for the acknowledged number? What's the value for the acknowledged number? Anyone remember? We take a guess. What's the value of the acknowledged number? Node number.
Randomly generated.
Correct.
Randomly generated? No.
No, the initial sequence number is randomly generated, but for the acknowledged number, acknowledged number is for what? Is to acknowledge the receive of one packet, right? But because this SYN packet is the first packet, so there will be no number. There will be 0, right? So this is the first packet. This is the ISN as well as the acknowledging the first packet. And when the server receives this connection request, it'll do what? It'll reply a SYN acknowledge packet, right? So, of course, here for the first thing you're gonna do is the server will hold a table, right? It will hold a table to recall the requested connection, right? For this table, for example, this client C1, this client says C1. So it will go through the table and find if there is a C1. And if there is no C1, it will put it in the table, create a row and record C1's information. Now, of course, there's some other like TCP preference settings, some IP information, and port information, all of those. It will maintain an entry for C1. And then it will return a SYN and acknowledged packet back. Now, what's the sequence number here? So what's the sequence number here? Yes, it will be another randomly generated number. So remember, in the first packet, the initial sequence number is randomly generated by the client. But for in the second step, the sequence number is the one that is randomly generated by the server. Okay, so let's say it's 3333. Again, it's not that short. It's just for the purpose of illustration. And now, what's the acknowledged number here? The purpose of this acknowledge number is to let the client know that the server, have received your SYN packet, right? Then here the acknowledge how can the server let the client know that it has received the SYN packet? It will set this acknowledge number to be this IC ISN +1, right? Because this random number is only known to the client. It's also known to the client. It's generated by the client, right? So by adding 1 to this number, the client can know that the previous packet, SYN packet, has received by the server. And then the last step, the client will send the acknowledged packet. Of course, it also contains the SYN number as well as the acknowledged number. So for this SYN number here, I'll just use the SYN number that is generated by the server, 3333. And for the acknowledged number here, I will use this one. I will just use 1002. So when the server receives this packet, it will check the SYN number. Okay, this value is exactly the one I generated in the previous step. So I make sure that this acknowledge is indeed from client 1, right? And here the acknowledged number also matches. So I can trust this. I can trust this guy. And one more thing that it will do in advance is the server, after receiving the ACK packet, the server will go through the table of lists to see if C1 has requested a connection before. If it's in the entry, then it will mark it as connected. So, or the connection is established, right? Then they will start the data transfer, right? If C1 is not here, is not in the table, means that the server 1 has not received any SYN request from this particular C1, then what will the server do with regard to this ACK packet? If let's say there's no entry associated with C1 in my record table, what the server will do to this packet? Any ideas? Someone take a guess? So here, if the server didn't find a matching entry in its record, then the server will simply ignore it, right? The server will just ignore this ACK packet, right? Because you didn't send me a request. Why did you send me an acknowledged packet? Right? It will just ignore it or send back a reconnection request. Tell the client if you want to establish a connection, you shall reinitiate the entire handshake again. Right? That's the reason why the server needs to maintain such a table. And that also will be the reason why the TCP SYN attack can be effective, right? SYN floating. Okay, let's come back to the slides. This one. So you need to know the TCP handshake. Not only it is important for understanding the denial of service attack, it's also very important for you to understand how the firewall works, how the ACL rules in a router can take effective. Right? So it's a very important concept you need to know. Also the SYN floating, the SYN floating attack. And similarly, there will be a TCP acknowledged floating attack, right? Right, as we say here, whenever the server receives an acknowledged packet, it needs to traverse this record table to find and associate associate entry, right? If there exists, then it will establish connection. If there is no such an existence, they're rejected. Right? Then what the TCP acknowledged floating do is you have a lot of clients sending sending numerous acknowledged packets to the server in a very short time window, so that the server is too busy handling checking those acknowledged packets that it will no longer have time to deal with the normal request. Right? So in this way, you cause a denial of service. And how you can defend it? We mentioned about the way we can potentially defend against the denial of service. There are several rules. There are different rules we can set to eliminate the malicious traffic. So go over them in the slides, and then we talk about the DNS poisoning. Again, the first thing you need to know is the background knowledge. What is the domain name system, right? And how they're organized, how for example, the domain name is organized, how so when your computer tries to visit a website, what's the process going behind the scenes? How those domain name is interpreted into IP addresses among your local DNS server and the major one, right? So these are the basic knowledge of the DNS, and of course the DNS caching. Why? So after your local DNS, so the client sends a domain name query to the local DNS resolver. The local server will contact the root server, the root servers for the IP translation. And if that is a new domain name to the local DNS server, it will cache it. It will put it in a cache for the future convenience, right? So the next time if someone requests the same domain name again, it no longer needs to asking the root servers anymore. Right, so we have the DNS caching. Then if you have put some those temporary data into the cache, it makes the vulnerability. It makes a security hole here, which means that as long as the attacker in order to spoof the domain name, the attacker no longer needs to attack the root DNS server or the authoritative name servers. Instead, it only needs to target on your local DNS server, which usually have a weaker security protection mechanism. Right? Then follow this logic. You know what the DNS poisoning is. Right? Basically, to use some ways to spoof the information in the DNS cache. Right? And if this part is being contaminated, the next time when the user wants to visit the same website, it will no longer visit the genuine one. Instead, it will be redirected to the one that is designed by the attacker. And we have talked about the TCP section hijacking. And at the very last, this is the intrusion detection system is our last topic. So particularly, we're more focusing on the network-based IDS. So we have two types, the host-based IDS and the network-based IDS. We're more in the lecture, we're more focusing on the network-based IDS. So you have, based on how, where do you position the IDS, and where do you position the NIDS, it will be inline and out of band, right? So out of band is the more common deployment. You don't want to put it in line so that it slows your traffic throughput, right? And you know that in a network system, you can place the NIDS in different sensing positions so that you have different views. Different views will give you different informations, helping you do certain investigation. And what is the challenge? What are the challenges in running the IDS? We have less few challenges relevant to the NIDS. And we have the algorithmic complexity attack. This is actually a very interesting one. Right, so for this particular type, you need to know that hashing operation is a very common technology we use in the pattern matching. Right, so the complexity attack, the algorithmic complexity attack is try to manipulate the input so that it can induce the worst performance of your hashing matching, right? The worst complexity for a hash operation is O(n) squared, right? If you have n buckets and all the input instance goes to one bucket, which has the n length, which has a link with n length, then the searching time will be O(n) squared, right? That's the worst performance. This is so this is what the attacker can do. And also we mentioned about the insertion attack, which take advantage of the partial knowledge of the NIDS, right? Because NIDS is some kind of a sensor detection sensing system deployed before your victim machine, right? So it only has the partial view, partial knowledge of the incoming network packet, right? So by leveraging this partial knowledge, the designer can send the TCP packet in a certain way and make some certain configuration, especially in the TTL value. to create a scenario where what is received by the NIDS is different from what is received by your host machine. So this is about the intrusion detection system, IDS. And IDS is a passive detection system. Just passively monitoring your internet traffic and alert alarm and erase alarm if something bad is detected. Now, a more proactive system is called the intrusion prevention system. And firewall is one particular technology under this umbrella. We talk about the packet filtering based firewall, where you monitor and filter the incoming, inbound, or outbound internet packet based on their header information. You check about you set rules to determine to check the source and destination IP addresses, port number, as well as the protocol that is allowed. So all these informations is translated in a series of ACL rules, right? The SS rules, and those SS rules are normally implemented in either in your host machine or in the router, right? And we in our slides we give a lot of examples how we can design the rule set based on the security requirement, and we show that some of the naive or simple rule set has some application limitations or the security holes, right? And how can we improve it? We show all these examples in our slides. You can go back and take a second look. So that's pretty much for all the topics we cover in our second half, and yeah, and that's pretty much it. Any questions?
Is there going to be any kind of like calculations, like problems, like in the first one, the midterm?
Calculations? I don't think so. There will be no PKI calculations, public key calculations anymore. So yeah, so a lot of the questions will be not I don't think it's proper to say it's conceptual wise, but description based. So as long as you understand the methodology, then you can write the answer.
Thank you.
Yeah, and for the vulnerability questions, for those long questions, I would say that the finals we develop it into two different zooms. You may find that the first half, not exactly to be the first half, but the beginning part will be more easy to handle. But for the last few long answers, it might be challenging. So just be calm. Just have some mental preparation for it. Don't be anxious when taking the finals. Just make sure you finish the easy questions. Finish the questions that you know first. Then you can regulate the rest. Use the remaining time to tackle the long questions. So in the long questions, there are some. I talk in the slides. There should be one question about the SQL injection, right? How you can manipulate the SQL input to achieve certain security goal, attacking goals. And there are also some questions relevant to the software vulnerability. For example, the input validation or the buffer overflow, right? We will give you an example, a piece of code and let you examine it to see if there's a potential security code in the, what kind of security problem you can induce based on the provided piece of code. So it might take some time to understand the short piece of code and develop your own idea. But I mean, just be calm and arrange your time more smartly. Okay. Because I believe, I think the short answers, the multi-selection questions, the true and false questions are quite easy as long as you understand the concept. Then those are quite easy. Oh, is it finished the grading? Let's see. Okay. Oh, it's not posted yet. Huh? So the solution for Homework 4 as well as 5 haven't been posted yet. Okay, I will let the TA, ask TA to post them immediately by today. I think it will not create any problem because we closed the submission window, so we will just post the answers right away. Okay, if no more questions, then we will end up here. And thank you again for attending this lecture. Hope you're doing well and prepare well for the final. And remember, we still have the homework 5 that needs to be submitted by next week, right? Yes, by next week. Okay, I will upload the video on the Blackboard in case you need to revisit this one. And thank you so much and have a good weekend.